It's the Electric Motor Conundrum by Sam. So here we are presented with the interesting conundrum of a electric motor created by a copper wire bent around a AA battery, which is resting on a very strong rare earth magnet. The problem which we are tasked with solving is what makes it work. So if we watch the video again, you can see that the copper wire is touching the positive end of the battery, and it's spinning counterclockwise. And one of the ends of the copper wire is just touching the battery, and the other end is just barely not. So now we have flipped the battery, so you can see the positive end is sitting on the magnet and the negative end is where the copper wire is touching. And so this one, the wire is spinning clockwise, and it's spinning much faster. Also note that it's bent in different ways, and that there's one end contacting the magnet as before, but the other end is much further away, and it's spinning much faster. So now we must add this into our complexities. So what's going on here is called Lorentz force. So when the wire coming from the battery connects to the magnet, it completes the circuit and allows for current to flow from the wire to the magnet. And however, when there's current flowing through the magnetic field of the magnet, it creates Lorentz force, which applied perpendicularly to the wire causes it to spin around. So, and then when you flip the battery upside down, then you're changing the flow from the positive end, the positive terminal here, going this way. It's instead flipped upside down. It's coming around this way, which then causes Lorentz force in the opposite direction, causing it to spin oppositely than it spins when the wire is connected to the positive terminal. And this entire setup is called a homopolar motor. Yay!